My name is Fabian and I'm a software engineer at K15T. And over the last weeks, I researched and implemented data residency for the Scroll Exporter apps together with my team. In this session, I want to give you a deep dive into the what, the how, and the why of data residency and how we implemented it. Okay, before we're getting too deep into data residency, I first want to give you a quick overview over the Scroll Exporters, so the apps that we're talking about, just so you have an idea. And so the Scroll Exporters are actually multiple apps that are part of the Scroll apps that we offer. And the Scroll apps help teams share their information at every touch point to enable their users and unleash the potential of their products. Now, how do these Scroll Exporter apps do that? The Scroll Exporter apps allow exporting content from Confluence into target formats. So for example, the biggest Scroll Exporter, the Scroll PDF Exporter, allows to create PDF documents, while the Scroll Word Exporter allows to create Word documents from your Confluence content. And we also have other exporters like the HTML exporter. And the cool thing about all of these exporters is that they allow you to customize the styling of the document that gets exported through easy to configure templates. And that's like especially useful if you have a corporate identity. So if your documents that you export need to have a specific styling. The first version of the PDF exporter was actually already published in 2009, and we're also already in the cloud since 2016 with these exporters. And since then, and just like last year, we published over 3,800,000 Confluence pages in documents. Yeah, okay. So enough of our apps. Let's quickly talk about data residency, what it is in general. So what is data residency? Many customers want their data to be stored in a specific part of the world. And this is for multiple reasons. Basically, either they want to have the control over their data, or they do it for legislation reasons, for example, GDPR. And data residency gives you the control over where your product data, so your Confluence or Jira Cloud site data, is hosted. And as a site admin, you can choose in a self-service UI between the different regions and move your data to them. So there is currently US, EU, Germany, Australia, and Singapore. And this is nice and it's really cool, but for some people, it's not enough that it's just the product data that is stored in a specific region. But they also want to have the same for the apps that they're using. And this is where data residency for marketplace apps comes into play, because with that we can implement data residency for our apps as well. So how does that work? Basically, data residency for marketplace app consists of two parts. First part is realm pinning. Realm pinning is basically offering a range of locations, which are also called realms, the app can be installed to, and where the app data must be stored. And these are the same realms that Atlassian offers. And once an app is installed, it stays in the realm it was installed to. If a site admin then moves the product data to a specific other realm, the app data is not moved over automatically. And this is where realm migration comes into play. So once an app is installed, the app data can be moved if realm migration is implemented for this specific app. Okay. With the rough stuff out of the line, let's talk about why we decided that we want to support data residency. Basically, there are like two reasons. We wanted to give our customers the control over their data. And this also enables customers with strict data protection rules to use our apps. And we also want to unblock existing customers journey into the cloud if they have specific rules that need to be followed. We have a lot of customers who are still on data center, and I think we can just unblock their cloud migration with this. Okay, so let's talk about how we implemented realm pinning. Again, realm pinning is basically just allowing the app to be installed into another region. And we did it by just deploying our app into another region as well. So the first thing we did was actually some preparations. The first thing that we did was that we ensured that our app was able to run in multiple regions. And we did that by just deploying our whole infrastructure that we defined with AWS CloudFormation into Europe. So our first instance of our app was basically running in the US, and then we just tried, hey, can we run this app in Europe? And CloudFormation made that super easy because we could just change the region that we wanted to deploy to, and the app basically was online there. We still needed to do some changes because we had some region stuff hard-coded, but overall, that made it made it super easy for us to just put an existing app and put it into a new region. Another thing that we did that is not required strictly for data for RAM pinning is that we changed our base URL. So before we had the domain scrollpdf.addons.k15t.com for the PDF exporter, but this didn't have any place for us to put a region into. But in order to implement round pinning, each app in each region needs its own base URL. And we're going to see soon why this is needed. So what we did is that we changed the URL to scrollpdf.us.exporter.k15t.app. And this made it like super easy. For example, when we added Germany, that we could just replace the US with a DE, and our app was capable, or we had a domain in Germany. So here's a pro tip. For new Connect apps that you're like still building right now, plan for data residency from the get-go. So what do I mean by that? So basically, think about using a tool like CDK or CloudFormation on AWS or whatever is available on your cloud provider that allows you to use infrastructure as code. And this just makes it so much easier if you want to deploy your app to a new region, because all of the infrastructure is defined and you know what needs to be done. It just makes your life so much easier. Then also make your code as regionless as possible. And by that, I mean, use environment variables wherever needed. And last but not least, if you don't have your base URLs settled yet, make sure that your base URLs have some place to store the region. Okay, so why is this region in the URL even needed? This comes basically down on how you announce round pinning, that you support round pinning to Confluence or Jira. So for each realm that you want to support, you need to add the realm URL to this new region base URL object that you can see here. So we all have this base URL in our app descriptor, right? But for each region that you want to support, you need to add the region-specific base URL to this object in our descriptor. And by that, whenever your app gets installed to Confluence or Jira, you will choose the correct base URLs based on the realm that the product's installed to. Okay, and that's it. That's everything you need to do in order to implement round pinning. Okay, to give you a short summary about round pinning. Basically, first of all, you need to make sure that, or like we made sure that our app was capable of running in multiple regions. And then we did the necessary descriptor changes to announce that we support round pinning through the app descriptor. Okay, that was round pinning. Let's talk about round migration. Before we go into the more technical parts about round pinning, let's quickly talk about how round pinning looks from the customer's perspective. So this is the security page, or like the data residency page in the Atlassian admin of our current organization. In this case, it's just my test organization, but you can see that my Confluence is currently pinned to the US, and it has 2 apps. And both of these apps are eligible to be moved, their app data to be moved, because currently all of the app data is stored in Europe, but we want to move the app data to the US. And for that, we click on Move Apps, and then we get to see the screen, and we can see which apps will now be moved over, or which data of which apps will now be moved over. And then we can select the time window. This time window is a 24-hour time window. And in this time frame, the product is actually shut down. So no, and this is great because as adminers, we don't need to think about if the customer data can change in this time, because the customers don't have access to Confluence, so they can't change the app data in this time. Okay. So this is how it looks from the outside and how customers can use it, but how does it need to be implemented? I once again go back to the Connect descriptor, and there is a lifecycle object in connect descriptor, and you probably already have an installed hook and an uninstalled hook in there. So what's new now is their migration path, which case, in our case, it points to /API/run migration, and there doesn't stand for that you need to be brave for anything. This just means that there is just short for data residency. And once you add their migration hook to your descriptor, you basically support run migrations, and migration events will be sent to this path. These migration events are actually sent by a special app migration service, and that's just because Confluence or Jira is shut down, so these will come from a special service. So what will you receive under this hook? So basically, under this hook, there will be some sub-tabs that you need to support. There's a schedule hook, there's a start hook, there's a status hook, there's a commit hook, and there is a rollback hook. And as the name kind of implies, the schedule hook, you get a request to the schedule hook once a run migration is scheduled. You get an event to the start hook once you should start with the migration. The status hook is for polling the status. The commit hook is committing the data to the new region, and the rollback hook is there in case something goes wrong. Okay, that's the rough overview. Now let's talk about how we implemented the run migration. Okay, so the first hook that we implemented is obviously the schedule hook. Schedule hook gets sent to you, I guess, whenever in the UI the create migration button is pressed, and it contains this event contains some general information about the migration. So the start time, the end time, and the target location. So the target where the data should be moved to. Now, what do we do with this data? We just pack everything up. We assign a migration ID to this migration or to the schedule. We store which tenant scheduled it, and we store the start time and the end time and the target location all into a database. However, what you can also do on a schedule hook, and actually on every other hook that you implement, you can also return an error. And there are like some error codes that are specified. For example, there is an error code in case you don't support a target region, but just so you can check if this target region is supported by you or not. And you can also reject migration if you already have too many migrations running at the same time. Okay, so the schedule hook obviously gets sent before anything else gets sent. But a few days later, you will probably get sent a start event. The main job of the start event is to copy, or like your main job at the start event is to copy the data from the source region to the target region. And this is where we spend most of our time actually implementing the run migration, because it's hard to get right which data needs to be collected, which data needs to be copied. So this is also where you should spend most of the time thinking about that question, and also which data can maybe be thrown away, because we had some caches, and obviously we don't have a copy of our cache data. Okay. Now the start event actually contains the same information as the schedule event, and we just verify that we're at least talking about the same target region, so nothing can go wrong here. And then we mark the migration as copying in the database. This is just to make sure that whenever a second start event comes in, we don't start another migration, because we can check is the status currently copying, and then we don't start another migration. And then we start a separate worker instance, which does the bulk of the work. What do we mean by worker instance? Well, as I already told you, these scroll exporters create exported documents. And since we wanted to offload the work of creating these PDF or Word documents from the main server, we have separate servers or separate workers that take care of that. And we use AWS Lambda and AWS ECS tasks for that, which basically are both ways to run containers on AWS. And we use the same infrastructure for these migration jobs. And we basically chose this for two reasons. The first reason is that we potentially have a lot of data to copy, and we just didn't want that to run on the same server and to take up resources there. And it also makes it easier to roll out updates, because if you roll out an update, this does like cancel a running migration. So we basically don't want to have it on the UI servers. Okay, but what does this worker then do? This worker basically just gets sent the ID that we assigned to the run migration when we created it in the database. And then it can like get all the information from the database and get the target location. It then does some validations with this data and see if everything's okay. But then it starts to check, and then it starts to copy the tenant row. So in our case, the database entry that contains the client key, the shared secret, the base URL of the Confluence instance and stuff like that, and copies that from the source RAM into the target RAM. And this is the most important step, because after the migration is finished, Confluence is only, or like you communicate with Confluence or with Jira, but through the new URL, through the new base URL. And if you don't copy over the 10 data, you don't have the shared secret and you cannot establish a connection here. After that, we also copy some other data. So I already explained that these role exporters are customized through templates, and these templates are stored in S3. So what we do is we download all of them and re-upload them in the new region. And we also have some API tokens that are stored in the database, and we also make sure that we copy over these. This obviously varies from app to app what you need to copy. And if you don't have any data stored outside of Confluence or Jira, you obviously don't need to copy any data. And what we then do is we mark the migration as ready to commit in the database. And this is needed for the next endpoint, the status endpoint, which we will discuss now. So the status endpoint is called regularly by the migration service, and it's just like for the communication from you to the migration service to know what's up. And you can actually return whatever you want here. So once we receive the schedule hook, we just return that the event was scheduled or that the migration was scheduled. And when we have a running migration, we return copying from it. But there are like two magic ones that you need to keep in mind. One, there's a ready to commit response. And if you say ready to commit, this basically means, hey, I copied all of the data of this tenant to the new region. And I'm now ready to commit. What committing is, we will talk about soon. And there's also the failed hook. And failed, and you can return failed in case something went wrong on your end and you can't migrate to the new region. And in this case, you will receive a rollback hook, which we'll also discuss later. Okay, let's talk about the commit hook. Commit hook is kind of like start hook, at least in our implementation. We first check if all of the data was actually copied over already. And if it's not, something went wrong. But if all of the data was copied over, we mark the migration as committing in the database, and we start another worker instance. In this case, this worker instance deletes all of the copy data that we just copied to the target realm in the source realm because it's not needed there anymore. And we also mark the migration as committed, and we're done. Okay, but what if something goes wrong? In case something goes wrong, we will receive a rollback hook. And the first thing that we did do in the migration, in the rollback event, is that we mark the migration as rolling back. We start another worker. This worker checks if any data was already copied, and if no data was copied yet, there's nothing to be done, nothing to be rolled back. But if the copy check was already started, we wait until it's done, and then we undo all its work it did in the target region. So here's a pro tip. Implement the commit and the rollback hook as mutually exclusive. Because if we by accident get a commit and a rollback hook for the same tenant, we will probably delete the data both in the source region and in the target region. Okay, so that's how we implemented it, but how did we test our solution? So we started testing by basically just sending ourselves some mock events of the Atlassian events towards personal deployment, and that worked out well. We moved the data over and it worked. But once we were happy with the solution, we wanted to give it a proper test that actually works with the Atlassian services. So what we did is actually we asked at the Echo help desk, and that's really nice. You can create some manual migrations there. This is basically like a real migration, but it won't shut down your Confluence instance, and instead would only migrate the app data. Shout out to the team at the help desk. It was really helpful working with you, and it was just a blast debugging with you. By the way, once you're in testing phase, it probably also makes sense to communicate with your customers that you will probably launch data residency soon. We send out emails, not to all of our customers, but just to our partners, so they can plan projects that may involve data residency. And that's basically all we did for data residency. Just to give a quick overview over the learnings that we had for RAM migration. Basically, the first learning is that we need to handle the RAM migration events, and I shared with you how we did it. And the other thing is that it was a good idea to offload the work from the UI servers to these dedicated workers, because for us, it simplified the whole migration implementation process. And that's about it. I hope you liked this quick deep dive into data residency, and I hope you could learn something from it. If you have further questions, hit me up on the events link. Thank you.